I will give a brief correlate on the physiology of skeletal muscle. So my references for this are Ganong and Guyton. Okay. So we'll be talking about only of the skeletal muscle, and I will talk a little on the neuromuscular junction, but I will not go in details of that because that will be covered in another module. But the general mechanism of the action potential in the neuromuscular junction will just be mentioned, not in details here. Okay. So let's review first the functional anatomy of the skeletal muscle. So from gross anatomy and then to the molecular level. So this is one muscle fiber composed of different one muscle tissue composed a bundle of muscle fibers. So a bundle is composed of a muscle fiber which is covered by your plasma membrane term, the sarcolemma. Okay, then the components of your muscle fiber are the different myofibrils, which in this case, in the myofibrils, you are going to appreciate the striated appearance of the myofibrils, and these are brought about by your different contracting filaments, your thin actin, and your thick myosin. So I want you to remember the different band, the A band, the I band, then the H zone, the M line, and the Z line. So for here, I just want to mention that your sarcomere is it is between the two Z lines. Okay. So here, this is your thin actin filaments, which are composed of three subunits: your F actin, the tropomyosin, and your troponin, and the thick myosin filament. So this is the arrangement of your thick myosin filament, and we'll talk about it later. So this is the sliding theory of contraction. So as you can see, in the relaxed state, so take note of the A band, the I band, and what are the changes when the muscle is already contracted as to the length of the sarcomere, the length of the A band, or if there are any changes in the different contractile filaments. And here, I want you to take note of the accessory proteins, which here, what is this? Your titin. Okay, this will connect your myosin filament to the Z line. And also, for the actin, there is also another protein here, right? Your actinin. And then the dysmin is located on your Z line that will adhere the Z line to your sarcolemma. So here, these are now the molecular appearance of your contracting filament. So your myosin molecule is composed of your two polypeptide chain wrapped spirally each other, forming a double helix. And at the end, so each polypeptide chain is folded globularly, forming the head of your myosin. And in each myosin head, you will have how many subunits of
light chain? Two light chain.
Of light chain, two. Okay. So all in all, there are 4 light chain. And it is your myosin head that has the ATP's activity, which is important later in your power stroke. So here you have the actin filaments, as mentioned before. You have your actin, your tropomyosin, and your troponin, which has again 3 subunits: your trop T, trop C, and trop I. And what is important during the power stroke is the attachment of your calcium to your troponin C. So here, so this is your sarcotubular system, which is important in the transmission of your action potential. Because it is here, in in the T tubules that the action potential from the motor nerve fiber will be transmitted. And at this point, I want you to remember that in a relaxed state, so what is the resting membrane potential of your sarcolemma? It's negative 80 to negative 90 millivolts. And that resting membrane potential should be changed into a less negative so that an action potential can be transmitted to your muscles. Okay? So here, imagine there is a neuromuscular junction. So first, let's talk about here the general mechanism of muscle contraction. So it will start with what? An action potential along the motor nerve fiber. Okay, and that action potential in the motor nerve fiber will cause the release of your acetylcholine in the synaptic space. Okay, so once there are acetylcholine, your neurotransmitters are in the synaptic space, that will cause the opening of what? Voltage channel, your acetylcholine voltage channel, which is located where? Which side? In the motor or in the nerve or in the muscle? So it's in the muscle side. So the opening of your acetylcholine gated channels will cause now the influx of your sodium ions. Okay. And the influx of your sodium ions will now cause the depolarization of your muscle membrane. So from negative 80 or negative 90, since your sodium ions are positively charged, so the potential will now be like negative 60 or negative 40. So that is now what we term the local depolarization. Okay. So after there is already the influx of your sodium ions, the change in the voltage of the muscle membrane will now be detected by what receptor? Your dihydropyridine receptor, which is connected to the ryanodine receptor of the sarcoplasmic reticulum. Okay, so if the dihydropyridine receptor has detected the change in the voltage, it will now make the ryanodine receptor to open, and there is now the release of your calcium ions. So with the release of your calcium ions, they will now diffuse to your contracting filaments. So here is now calcium ion. So in a relaxed state, the active sites of your F-actin is covered by your tropomyosin. So when your calcium ions bind to troponin C, so there will be now uncovering of your active sites. Okay? And also remember that during the resting state, in the myosin head, there is already an ATP attached to it. And at the same time, it is already cleaved by your ATPase. Okay? And the molecule that is attached in the myosin head is already in the form of your ADP plus the phosphate ion. So here, this is now the walk-along theory. Okay, so there is now the unveiling of your active site. So this will now cause the myosin head to interact with the actin. And then the interaction of your actin and myosin will now cause a conformational change, causing your head to tilt towards the arm. Okay, then upon the tilting of your myosin head, ADP is released. Then at the time of release, another molecule of ATP will bind to the myosin head, causing the detachment of the myosin head to the actin. So there is now the relaxation. So here, I want to talk about the Fenn effect. So what is Fenn effect? I just just tell that if there is more work to do with a muscle, so there is an increased need of ATP. And I want you to remember the different sources of the ATP, but at this point, we'll not talk about the biochemical events for the glycolysis that will be taken on the next bi-monthly. So suffice it to know what are those three sources of your ATP.
Next by? Second by pa? Ang
the biochemical.
Okay,
Oh,
the
true, but
oxidative
we need to know
metabolism and the anaerobic metabolism.
Kasi kasama yan issue.
Any questions so far? Clarifications? So this is another slide depicting the power stroke, and I want you to remember here that the contraction continues. The cycle continues if ATP is available and calcium level in the sarcoplasm is high. Okay? Because if ATP is already depleted, there's such a thing as your muscle fatigue. Okay? So we are done with the muscular contraction, the general mechanism. So at this point, we'll have to define some terms. So we have, I hope you have discussed in your SGT the simple muscle twitch, the incomplete tetanus, and the complete tetanus. Okay, your simple muscle twitch is that there is only a single action potential, causing contraction and then relaxation. For the incomplete tetanus, there is contraction, but before there is a complete relaxation, another action potential is there to cause contraction. And then for the complete tetanus, there is no relaxation at all. So here, we will be talking about the different characteristics of contraction, your isometric contraction, and your isotonic contraction. So with your isometric contraction, there is no change in the length of the muscle, but there is a change in the tension. Okay? For your isotonic, there is a change in the muscle length, but the tension is constant. So what will determine the tension of the muscle fiber? So it can be determined by the muscle length of the sarcomere, and specifically the number of cross bridges or the action of the myosin and the actin will determine the tension that will be created during muscle contraction. And in your book, there is a figure depicting the passive tension, the total tension, and the active tension. Okay, you have to know that. So at resting length, so there is your maximal contraction, right? Okay. So this is just an illustration of when to appreciate isotonic and isometric contraction. Okay, this is my last slide. So you have that. We talk about the tension. What is the effect of
Shadow
tension?
ka lang.
Yeah, then the effect of the load and the velocity of muscle contraction. Okay, so the load and velocity, the relationship is inversely proportional. So if there is an increased load, the velocity of contraction is lower or slow. And then for the muscle length, it has also a relationship with the tension. And then for the strength of stimuli, I want you to study about the size principle. Okay, the smaller fibers will be stimulated first if the stimuli is slow or weak, because your small motor fibers are innervated by your small nerve, which is more sensitive. Then also the frequency of stimulation. Any questions? That ends my correlate.
I almost read.
Do you agree?
Fun.
So any questions? Just study, just focus.